Hi everyone. My voice is so loud now. Okay, I know some of you. If you don't know me already, please raise your hand so I can see a bit. Okay, cool. Does any of you have already been to CP3? You have been. You? Yeah, you've been. Okay. So I'm going to present today CP3, which is Concordia Precious Plastic, but I'm also going to present Atelier Écodesign, which is a similar project happening at Cégep du Vieux Montréal. And I'm now the coordinator of Atelier Écodesign. Atelier Écodesign was started by Yolande Turcotte and Jacques-Olivier Roy, and I'm now joining the team. These two teachers will also have a group of students this year, and they will be together designing a product from scratch. So everything will happen at Cégep du Vieux Montréal near the entrance. And it's a new building where everything will be organized to facilitate the recycling of plastic objects. And in the new building, there will be, not new building, but the new room, there will be a press, vacuum former, an injection machine, and a laser cutter. And with these technology, we're able to transform a little bit the plastic. So, as I was saying, these two will also, and I will help too, go through the process of designing a product from scratch until Christmas, and they will be called the Collectif Reproduit. Okay, CP3 is a bit different. So CP3 is led by students for students, and they are situated at Graynon's residency. So the goal is a bit different. Oh, I thought I had a plan of that. But it's near soccer, where like close to them, we want to enable you to bring your plastic to CP3 and basically do your student project there. Also, in Montreal, there's another place called Precious Plastic Montréal, and they are at l'Espace Maker. And these people are more working on the community aspect of precious plastic. So they organize meetups, they help a new initiative find machines, and they can also guide some people who want information towards one of the two initiatives or the newer ones. Okay, so what is precious plastic? Do any of you know what is precious plastic? Have you heard of it before? Probably you. So precious plastic was the idea of Dave Atkins, and with a group of people, he designed machines that are open source to transform plastic material, plastic waste, into new objects. So what was good with that project is that the machines were open source, so it allowed some people to get into plastic recycling that did not have the means of doing it before. So inspired by this project, we started our own, and we're doing things a bit differently, but I'll present a bit the project we do, and after that, you'll see a bit how we proceed. So first, to know the difference between like your regular recycling that you do at home and the recycling that you will do at CP3 or Atelier Écodesign. We'll have a look at how recycling is usually done. So there's like 3 parts of recycling. There's like when you collect the material, which is when you put your stuff in the bin, and there's a truck that comes, pick up the stuff, and bring it somewhere else. There's a triage, sorting that happens where the plastic will be sorted into different types of material, and it will be transformed in either like a big block of plastic or like pellets or something that can be sold to a manufacturer, and then there's the manufacturers. So can someone tell me where does like recycling actually happen in that sequence of events? What? Yeah, because if you think about it, until plastic is into a new product, it's not actually recycled. It's just been collected, it's been sorted, but if it ends up in the landfill, we're not better. So, is this working? Oh no, so this is not working, sorry. It was a link to a video, but it was showing the way in which the plastic is sorted in this sorting center, I would say, the centre de tri. And it's a bit pixelated, but you can see there's a lot of people actually sorting the stuff. So there's manual labor involved in sorting this material, even when it's in a big sorting center or in a small project like ours. So why don't we recycle? Do we see it? No. Can you help me?
Partage ton écran. Donne-nous share.
Okay, thank you. So this is a bit old. It's from 2019, but it still is interesting for the comments that the people do during the interview.
Pour faire votre épicerie de n'importe où, réinvente l'épicerie en ligne. Voici, voilà, un nouveau service hyper précis avec livraison à temps. Voilà.
La matière, elle vient partout dans le monde. On a un exemple ici. Là,
Dans cette usine, avec ses granules de plastique qui proviennent de partout dans le monde, on fabrique plus de 2000 produits différents. Ici, on préfère utiliser de la résine de plastique neuve plutôt que de la matière recyclée au Québec.
Ce matériel-là, c'est un matériel de première qualité. C'est un matériel qui vient de la Corée. C'est un acétal. C'est un matériel coréen qui est en importation.
Comment ça se fait que vous devez acheter de la matière première en Asie?
Dans ce cas-là, c'est purement une question de coût. Pour nous, transformer de la matière recyclée est plus coûteux que de transformer de la matière vierge.
Les centres de tri ont envoyé l'an passé 59 000 tonnes de plastique chez les conditionneurs. Avec la chute des prix et le fait que les matières neuves et recyclées valent la même chose sur les marchés, la plupart des fabricants de produits de plastique achètent maintenant leurs matières premières à l'extérieur du Québec plutôt que chez les conditionneurs québécois. Résultat, les conditionneurs ont de la difficulté à vendre leur plastique, ce qui vient des centres de tri.
Moi, je dis que c'est une industrie qui est en train de mourir. Si les prix continuent à baisser, je vais être obligé de fermer avec le temps, là. Comme plusieurs conditionneurs au Québec qui ont de la difficulté, là.
Pour ce conditionneur aussi, les temps sont difficiles. Il a réduit sa production de moitié.
S'il n'y a rien qui change, des gens comme vous, les conditionneurs, ils vont en avoir de moins en moins au Québec, là.
De moins en moins. Il va rester deux portes de sortie. L'exportation ou l'enfouissement.
À ce point-là.
On est là, là. On est là, là. À un moment donné, il n'y aura plus un entrepreneur qui va vouloir investir là-dedans.
Au Québec, seulement 25 % du plastique est recyclé. Presque tout le reste est envoyé à l'enfouissement.
Le gouvernement du Québec devrait nous écouter, premièrement. Devrait avoir une volonté probante de faire bouger les choses.
Dans l'industrie, on croit que le gouvernement du Québec devrait forcer les entreprises à avoir un contenu de matière recyclée.
Il faudrait obliger les gens au Québec, ceux qui prennent la matière première, qui prennent aussi du recyclé.
Oui, le gouvernement du Québec devrait obliger de le faire, mais le gouvernement du Québec devrait aussi obliger le consommateur à acheter les produits qui sont faits de recyclés.
2 ans après la crise qui a frappé le secteur du recyclage, les défis demeurent considérables tant pour l'industrie que pour le gouvernement du Québec, alors qu'on parle de plus en plus d'économie circulaire. Ici Jean-Philippe Robillard, Radio-Canada, Montréal.
Avec les boîtes repas HelloFresh,
Okay. So in that presentation, we saw that there's many reasons why people don't want to recycle. There's the first thing that the manufacturer said, it's more expensive to buy recycled plastic. He also says that virgin plastic is a higher quality. There's also the fact that these people kind of throw the ball at each other. They say like, well, the manufacturer should be obligated to use recycled plastic. Then the manufacturer says, well, the consumer should be obligated to buy recycled plastic. So there's this question of where is the fault, or who has the responsibility to use, buy, sell recycled plastic. And there's also another thing, it's that the plastic recycling is hard to do at a small scale. And that's a problem for accessibility. So smaller businesses have a hard time to do recycling because it costs too much. The equipment is too big, too hard to have. So these are the main reasons why we don't recycle that much here. So even though I didn't show you the video of the sorting center, I can explain to you that it's going through a conveyor belt, and like a lot of the plastic is picked up by the staff and it's sorted by the machine, but a lot of it also just cannot be taken by the factory or the sorting facility, and these will always end up in the landfill. For example, here is the explanation on how to recycle your lids on your bottle. You don't have to read through all of it, but it's quite complex to know what to do with the lids on your bottle. And sometimes it will just not be recycled. They say like, if there's no number on the lid, actually don't put it in the bin. But these plastic can also be recycled if we take care of finding what type of plastic they are. So there's always a possibility for smaller projects to recycle these material that in French we call matière orpheline. So for example, this that I have here is made from Invisalign braces. They're made of plastic and they don't go in your recycling bin. If you put them in the recycling bin, they will just end up in the garbage at the end. So if we can make a partnership with a community member that has this type of material on hand and want to get rid of it, then we're able to process that, even though it's not processable, I would say, by the regular recycling stream. So how is CP3 and Atelier Écodesign different from your regular recycling stream? I think that by looking a bit at the projects we did, we can start to spot the differences. So if we look here, we have a vacuum form flower pot. So by carefully sorting the plastic, we can select plastics that are easier to vacuum form. Usually when they sort the plastic at the facility, they will sort it only by number, but there's also variation in the plastic numbers. And they will probably always mix the colors too, so you get like a gray plastic. But here, we're able to take plastic that was made for vacuum forming or that was made for blow molding and reuse it for its intended purpose. So here we have, in this jar here, a mix of blow molded containers and a cheaper also HDPE, number 2 plastic. And by combining those together, we were able to achieve this kind of shape on the vacuum forming machine. Here we have another project that uses the CNC machine to cut earrings out of sheet material that we made on a hot press. And this project was also led by students in the business department. So in that way, the team that worked on that project was able to experience an interdisciplinary learning activity. And they got to work on an object that they could put in a store at the end. So we also have a partnership with La Friperie, La Chiffonnière, yeah, thanks. So this is Catherine at La Chiffonnière, and she agreed to have some of our objects that we designed here at Concordia at our shop. So we are very happy about that, and we say thank you to her. Another way that we operate at Concordia is with partnership with the labs. So here you can see some coasters and a cat, and these were made out of PLA. So PLA is plastic that is often used for 3D printing, and we grind it up in small pieces, and we have a machine that is a bit dark in the picture, but it's a machine that can re-spool, remelt filament for 3D printing. So the little cat you see was 3D printed with the waste from the sandbox with the 3D printer at the sandbox. But we also made some coasters from the same plastic. So we're actually discussing another partnership where we're going to make some plastic boards to cut with their CNC with the PLA that cannot be remelted to make new filament. Here we partnered with a business that has a lot of zip ties in their manufacturing process, and we sorted them and removed all the contaminants. We also did a training session there to inform the staff on how to properly collect and sort the zip ties. And we are working with Atelier Écodesign to produce clips that you can see just beside the little petri dish and the zip ties. There's like a bag clip, and because zip ties is made of nylon, it should create a fairly resistant clip. And this uses the injection machine that they have at the Atelier Écodesign, or I should say that we have. And yeah, I'm a bit confused because I'm in between the two. I'm transferring to Atelier Écodesign, so sometimes I confuse a little bit. Another way that we operate, sometimes we bring in groups that want to recycle something, and we have them dismantle objects, and during the activity they can leave with an object after. So the library at Cégep du Vieux Montréal had many VHS tapes that were bad, so they gave them to us, and we were able to shred them into these tiny bits that are black, and the white stuff in it is also waste from Cégep du Vieux Montréal. It's waste from the vacuum forming machine. So they use a lot of polystyrene sheets on the vacuum forming machine, and we mix these two together to get this black and white pattern, and we use the bread bag tags to give it some color. Also, it's fun because on the bread bag tags there is also the date, so it's a bit of a history on the object. Is it all? Yes. So the advantages of our approach is access mainly, I would say. So a lot of these technologies are hard to access if you're not working in a big company that makes tons of plastic objects. And to have diversity in the objects that are produced, we need also diversity in the side of the people who design the objects. So it gives the chance to different people to bring objects to the world. Another thing is, when you recycle in the regular recycling stream, you put your stuff in the bin and then you don't think about it. It just disappears. It's kind of like magic. It's even too good to be true. But when you recycle at CP3 or at Atelier Écodesign, you get a chance to collect yourself the plastic, melt it yourself, process it, and you end up with an object that you can do whatever you want with. And that's a very empowering experience, I would say. Another thing that's interesting is you can trace where the plastic comes from and advertise it on your packaging. You can also make sure to do a follow-up with the people who gave you the plastic in the first place and say, look, you gave us some containers and we made some flower pots with it, and that way you can ensure that the plastic gets recycled. It's not just a collection of plastic. And at CP3 particularly, it's a mix of people, because to keep CP3 alive, we need also people who work on the website, who work on the communications, and all these people come together and work together, and it's like a mini society where everyone has his strength and weakness, but we are also not confined to our role, and we can learn from each other's skill. And to me, it was a very useful journey, I would say. And lastly, as we will see with the Collectif Reproduit, it's an opportunity to develop small businesses slash project that are geared toward sustainable development. So if you have like this value at heart to create sustainable projects, then it's going to be easier to do in a community-based project than, like, let's say in a private enterprise where like cash is the first thing that's important. So it's great to recycle at the community level, but there are still challenges that we need to overcome. Specifically at Concordia, we would like to see more involvement from the teachers in the CP3 project. Not only like we need this amount of plastic, but like could we come to the lab with our students and make some sheets of plastic? That would be helpful to also legitimize the project. A collaboration between the departments. So CP3 has members from any department, but sometimes because we're not working in a specific department, it becomes hard to do our project at different labs. Or let's say I want to use the CNC that's in engineering, then it becomes hard for a member that's not in engineering to access that lab. So I have no solution for that already, but I think we could find a better way to operate. So I said access to laboratories. That's something that I put almost twice. And we also would need some employees that are there full time so that we can have students like you come in the space and work on their project. Because for now, we need always to have one supervisor that is a voluntary member of the CP3, work with a student, and it's a lot of energy that is expended toward that goal. So having a full-time technician there would be of great help. And I think that's it. Do you have any questions?
Sorry, Clara.
Thanks so much for that great presentation. It's really exciting to see all that stuff. I'm curious, given all the great projects I've seen so far, and given like sort of the constraints of processes like the vacuum forming and injection molding, if you guys have noticed any sort of what works best? What kind of objects work best to create? Are there any design principles that you've developed through your experiences creating these different kinds of objects?
I would say that anything that's made from sheet material is easy to make. Anything that's 3D shaped is harder to make. You need more tooling. So products that also have parts that can be assembled onto them are often a good project. People like them. And especially for the plastic that cannot be recycled many times or that you won't put in the recycling bin anyway, it's not as bad to have hardware put onto them because you can basically use that for 50 years if you want, no problem. So yeah, the things that have like little hooks like this, earrings, they've been a great success. These ones, the Instagram page liked it very much. Yeah, I would say that anything that's made of sheet material is easier to produce.
Fantastic, thanks.
Hi. I know that you just started in this role, but I'm just curious because, we're in a university setting here, so, people are maybe sort of more aware of these concepts and these sort of initiatives, but like at the Cégep level, do you get a sense that the students are like passionate or excited or curious about recycling plastics? Like, is there kind of like an interest? Are they seeking this out? Or is this kind of something that you're really like showing them for the first time and, they hadn't considered this before, or, what's your sense of that?
So I just got to Atelier Écodesign CVM, but the project was there before me. So a lot of the students already did interact with the project at some point, and they have had collection bins around the campus for 2 years, I think, already. so they know it a little bit. But they come to the Cégep needing to learn a lot of the skills that they need to learn to be designers. So they don't know already everything about plastic, and we have to show them, and that's normal. I would say that they have, I think they have a schedule that's very full, especially in the industrial design program. So they sometimes need a little push, but I believe once the glue sets between the small group of students that we will call the collectif reproduit, then they'll be self-motivated. Yeah.
Ah, damn, he won't ask it for me. So, Martin, you talk about biomimicry, natural mycelium, and cradle to cradle. Félix, you're talking about plastics, which are man-made. How do both of your researches, how are they compatible? How do you see what you're doing in terms of the unnatural plastics that we have way too much of in relationship to Martin's manifesto of biomimicry? I need both of you to answer this.
Well, this project is about the technosphere. So you know, in the circular economy, you have the biological sphere, the biosphere, and the other loop is the technical sphere. So basically, this project is about keeping products inside that loop. So basically, what I think you have expressed through, especially with the document from Radio-Canada, saying that basically there's an issue in the system. The technical sphere has a difficulty to close the loop. Oh, thank you. Because of, you know, market issues, cost, and so on. So again, we need. I think the head of that plant was right. We need governments to, favor, value or even impose the use of recycled materials inside a product. Otherwise, the system is based on the make, waste system. So we need to make a transition here. So basically what you're exploring is all sorts of ways to add value to products that are being, plastic products that are being disposed, and in many cases it's recyclable, but it's not because of the cost and so on. So it ends up in wet landfills. So we do have the technology, we have creativity to come up with ideas. Of course, I'm very familiar with the world of plastics because in an earlier stage of my career, I worked a lot in this area. And I know, one thing I can tell you young designers is that it's important to know the color, the coding of the plastic to identify the different resins. Because we say plastic, but in reality, these are all different types of resin: polypropylene, PVC, polystyrene, ABS, and so on. They all have different properties, and they need to be recycled together, ideally. Now, what you're doing is also experiments mixing stuff together. That's another technology where we create this mix of all sorts of plastic resin. I worked for Cascade, actually, and we worked on a lot of projects related to this aspect. But the reason I'm telling you this is that this is our role as designers when we're designing a part, to identify. When I was working, and that's a long time ago, the coding of plastic had just been kind of developed. And then I said to my boss, well, let's add the coding, because we were doing all these plastic products like kitchen utensils and kitchen accessories. And I said, let's add the code. And he was like, yeah, why not? Let's do this. Otherwise, nobody would have thought about it. So it's important, and that's our role as designers. In whatever field you work in, you need to be the driving, to use the place where you can have a true impact in intervention. And that's labeling, in fashion design, in graphic design, same thing, and object design, trying to find all sorts of things to facilitate the reintegration of products at the end of their life cycle in the technical cycle?
On my part, I would say that first that we don't mix that much plastic. We have like we also have a sorting system. I put the number 2 underneath that because it's only HDPE, but for sure there is sometimes contamination. But usually we keep like our plastic separated. But when it comes to the biological side of design, there's also the idea for me that it's all work, you know, the recycling task. It's like labor and it's work of care. And I believe that by creating beautiful objects out of this material, we honor the care and work that was put into sorting, collecting this material. So in that sense, this is where the value lies in recycled plastic. It's in the care of the people who worked throughout the chain that led to the production of the final item.
I agree. I think that's where design, you know, adds value to the quality of the design. Instead of broken plastic, you know, just people throw that in the trash, or we add value. So I invite students to consider this, I guess, opportunity to explore the use of this material, explore that, because plastic, you know, I see interesting avenues for the creation of a lamp because of the possible transparency and translucency of, if you have thin layers of plastic, you can do very nice translucent lighting effect. So I think there's an avenue there, and also exploring how to connect things together. I think you saw the work of David Trubridge, you know, this New Zealand designer who creates these fantastic globes and all sorts of a whole line of products. I think you could do exactly that with reusing plastic. If you use just a sheet of plastic, cut out with a laser cutter, create those star-shaped forms and connect them together, and there you go. You have a very interesting concept.
Yeah,
so
and the challenges will always be with the plastic to assemble the stuff together in a way that can be disassembled, no glue. And anyway, most of the plastic that you'll use at CP3 or Atelier Écodesign is very hard to glue. Number 2 plastic is notoriously hard to glue, so we always favor mechanical fasteners. Yeah.
I'm just curious. Whoa, that's so weird. About the size constraints of this material. Like you said that it's easier to make flat sheets of them.
Yeah.
Of it. So I'm just wondering if you guys at either CP3 or the new one have made anything like on a larger scale.
Actually, we have a new intern at CP3 who's going to work on a larger scale project. So what I would suggest is to make a mold of one part that's constrained to the size of our press, which is about a square feet. And you could create the outline of your part that you need in the plate. So you can see there we have the hexagonal shape in the plate, and we melt that with the press, and it creates these hexagonal parts. So if you would like to make a larger object, you could make a mold with one part that is repeated, let's say around the sphere or on a wall, and that way you could create a larger object from smaller parts.
So, Martin, Félix, we have about 8 minutes left. Is there anything that you feel you'd like to present to the students from your talk that maybe you missed or you'd like to add?
Don, did you have a question?
Yeah, I guess if I may. So as I was considering, the requirements of recycling, right, and that cradle-to-cradle process, one of the principles seemed to be like simplicity and the ability to like pull these materials out into their constituent parts. And then I was considering Martin's talk about sort of imbuing objects with the stuff that makes us like them enough to care for them for a longer amount of time. And in particular, some of those DNA principles about emotional objects and objects that communicate with each other. And I was considering sort of if you see or how you might resolve any tension between that desire for that cradle-to-cradle simplicity and reduction of material usage and the technological and material and industrial overhead of making your blender scream or your T-shirt talk to your car.
Yeah, well, that's why in the DNA project we had a very systemic view of design. We tried to put the most all the different levels of relations with objects, from care for the descendants, that's the end of the life cycle, level of attachment, communication, design for disassembly. So we try to put all the different parameters of our link with objects. So I mean, for students, they have in the past, for example, in this class, created sharing of lights, lamps that you would share, and you would actually. So it was kind of a playful object. You would use it was to sensitize people to also the consumption of electricity, of energy. So to turn on the light, you would take 25 cents. You put this in the lamp, and then it would turn on for a number of minutes. And then, so that was the idea, to have an object that actually to sensitize. So there we integrated technology, to add that level of, say, interaction. So I invite all of you students to explore those. I mean, next week we'll be starting workshops with Elio to add like how to work with sensors and how to trigger. Well, one very nice also concept was, again, in terms of emotional attachment, was that you have the base of the lamp and you have this kind of orb that was 3D printed. And to turn it on, you would take the orb and place this kind of globe, plastic globe, on the support, and that would turn it on. There was a magnetic sensor, and then that would turn it on. So it adds to the playful interaction you have with objects. Another concept was these modules that could be connected together to create a bit like these structures here. So basically you had this hexagonal volume that could connect. Now I believe at the end it was a cube, because it was so complicated at the end to create all these magnetic sensors. But those, oh yeah, now I remember, it's a truncated cone, and that's what so again, you could connect the parts, turn them on. So again, with the lighting, you could create this sort of magical and playful relation, and that's what I'm going to talk about in this class to stimulate students to explore that. But I like, I think it's very important to talk about materials right at the beginning of the process, because to consider the materiality of the lamp right at the beginning of the process, and then try to have we're at the beginning of our project in DART 447, so it's the time to be opening the spectrum of possibilities, imagining a lamp that does this, that, and that has all sorts of potential kind of interactions. And then from that, try to come up with the most interesting ideas. And I hope this presentation has stimulated students to think in a more in a global way. We'll be talking about lighting and lamps and so on, but we'll be also considering all the emotional attachment, or communicate the idea of the time capsule that I was, in this project you have the potential to add, the history of the material. It used to be a cassette, now it's an object, and so you have this, but you need to communicate that to the users, to the public, and that can be done through, technology like AI or the internet or QR codes to link that to a communication system. So that's the kind of efforts that I'm also asking students to do, because we're not only designing a lamp, we're designing a system that informs the end user what's going to, at the end, what happens at the end of life or at the beginning of the life, trying to find a system. So that's my perspective on this.
I would say that as far as technology is concerned, if you want it to be sustainable in your project, it could be open source or repurposable. So that if you have, let's say you need a brain in your project, then the brain can be taken out and used for something else later if ever the lamp is no longer desired. And if you make that knowable to the user, they might want to do that.